You know that feeling when you type a question into an AI and a perfectly written answer just appears? Well, today we're going to pry open that black box. We're going to see exactly how these large language models take a simple prompt and turn it into eerily human-like text. It really can feel like magic, can it? You give it a command and it just writes. But you know it's not really magic, right? It's a fascinating step-by-step process. And in this explainer, we're going to follow that entire journey, right from your keyboard to the AI's final word. So here's the game plan. We'll start with the secret ingredient that makes it all possible. Then we'll walk through the two-part assembly line that actually builds the text. After that, we'll see how we can jump in and play creative director, look at the real-world hurdles, and finally wrap up with why knowing all this stuff really matters. All right, first things first. What's the one core concept that separates modern AI from everything that came before? It all boils down to one incredibly powerful idea: attention. To get what that means, just look at this sentence fragment. If I asked you to predict the next word, your brain would immediately latch on to a couple of key words, right? You're not giving every single word equal importance. And that's exactly what the AI is doing. Just like us, it instinctively knows that France and capital are the most important clues in that sentence. The model gives those words way more attention to figure out that the next logical word is a pretty safe bet: Paris. So officially, this is what we call the attention mechanism. This is the whole magic trick. It's what allows the model to truly understand context. It's the difference between an AI just spitting out random words that often appear together and one that generates text that's actually coherent and makes sense. But here's the catch. This attention isn't infinite. Every model has a context length, which is basically its short-term memory. It's the maximum amount of information it can hold and pay attention to at any one time. Sure, a longer context window is better, but it comes at a pretty steep cost when we talk about speed and power. Okay, so we've got the key ingredient, attention. So how does the AI actually build the text? Well, it happens in a really methodical two-phase process that works just like a high-tech assembly line. The first phase is called prefill. You can think of this as the prep phase, where the model takes your entire prompt and digests it all at once to understand what you're asking. The second phase is decode. This is the actual writing part, where it generates the response one single word at a time. So during that prefill phase, your text first gets broken down into little pieces called tokens. Those tokens then get turned into a series of numbers that the computer can understand. And finally, the model processes all of those numbers at once to get a deep sense of the context. This is the heavy lifting, the really computationally intense part of the process. And then the decode phase kicks in. And this is a loop, right? For every single new word it writes, the model looks back at everything, your prompt and what it's already written, calculates the odds for every possible word that could come next, picks the best one, and then decides, should I stop or keep going? And it just repeats that cycle over and over. Now, this is where it gets really fun. That token selection step we just mentioned, we can actually get in there and influence the model's choices. This is where we get to put on our creative director hat. The most common tool for this is called temperature. And honestly, the best way to think about it is as a creativity dial. If you turn the temperature down low, the model gets really conservative. It'll always pick the most obvious, predictable word. But if you crank it up, it starts taking more risks, getting more creative, and yeah, sometimes a little weird. We can also help the model narrow down its options. Instead of choosing from its entire massive vocabulary, we can use strategies like Top K. That's like saying, hey, just give me your top 5 most likely words to choose from. Or there's Top P, which is a bit more flexible. It's like saying, show me the most likely words and just keep adding to the list until their combined probability hits, say, 90%. And to stop the AI from sounding like a broken record, we can use penalties. A presence penalty gives it a little slap on the wrist for reusing any word it's already said. A frequency penalty goes a step further and makes that penalty bigger the more a word is repeated. It's all about keeping the output fresh. And for the really high-stakes stuff, when you need the absolute best quality, there's a strategy called beam search. Instead of just picking the next best word and hoping for the best, it actually explores several different sentence paths at the same time, kind of like a chess grandmaster thinking 5 moves ahead to find the absolute best play. Okay, so all of this sounds great in theory, but let's get a reality check. How does this actually perform out in the wild? Because this whole process has some pretty big challenges, especially when it comes to speed and resources. When you're running these things for real, developers are basically obsessed with 4 key numbers. Time to first token, how fast does that first word pop up? Time per output token, how quickly does the rest of the text stream out? Throughput, how many people can use it at once? And the big one, VRAM usage, or how much incredibly expensive GPU memory is this whole thing eating up? And this all comes back to that context length problem. Yeah, feeding the model a giant document is awesome for context, but the memory required for that just explodes. We're not talking a one-to-one increase. It can grow quadratically, meaning if you double the context, you might need 4 times the memory, all while slowing everything down. So, how is any of this even possible with long documents? The secret weapon is a brilliant optimization called the KV cache. Seriously, just think of it like the memory button on a calculator. Instead of redoing all the math for the prompt every single time it generates a new word, the model stores those intermediate calculations in this cache. By reusing that work, it makes the generation phase dramatically faster. This is the hack that makes giant context windows practical. All right, we've torn the whole thing apart from prompt to final word. So why does understanding all this gritty detail actually matter? Let's put all the pieces back together. The big picture is this. We've gone from seeing AI text generation as pure magic to understanding it as a clear, logical method. Remember, attention is the heart of context. The text gets built in a 2-phase assembly line. We have a whole bunch of knobs and dials to control its creativity. And finally, clever optimizations like the KV cache are what make this whole thing run efficiently in the real world. Look, understanding these mechanics isn't just for developers. It actually empowers you to write way better prompts, to tune models for exactly what you need, and to figure out what's going wrong when it doesn't work. So I'll leave you with this question. Now that you've had a peek inside the engine, what are you going to build with it?